No. Generally, you should know the following. Number one, you know metals, non-metals. By the way, how do you know that an element is a metal and another one is a non-metal? I have already said that. There's a video for that. You can check it. So for now, you should know that a metal, generally that a metal plus an acid, you should know the names of the acids. We have hydrochloric acid, nitric acid, sulfuric acid. So when a metal reacts with an acid, what do they form? You should know that a metal plus an acid, the answer is the metal salt plus hydrogen gas. So for example, when I give you zinc plus sulfuric acid, it forms zinc sulfate, zinc sulfate, zinc sulfate. You can see it is the metal salt. The salt comes from the acid, and then plus hydrogen gas, right? Number two, metal plus steam. Steam is water but in vapor form. So what does it form? A metal plus a steam, you should know that it forms the metal oxide plus hydrogen gas, right? For example, magnesium plus steam, we write it in gaseous form, it will form magnesium oxide plus hydrogen. So when you know that this general information, it becomes very easier for you to write the products. Number three, metal plus water. What do they form? A metal, any metal, if a metal that is able to react with water, it will give you the metal hydroxide. Metal hydroxide plus hydrogen gas. Very important. An example is magnesium plus water. Now this water is a liquid form, solid. This one will give you magnesium hydroxide plus hydrogen gas. The equation will need to be balanced. So we are not talking about the balancing, but that's how the equation will be. But we have to put 2 here to balance the equation, as simple as that. Number four, metal plus oxygen. A metal plus oxygen, we just get the metal oxide. Metal oxide. For example, sodium plus oxygen. This one is a gas, this one is a solid. What does it form? It forms sodium oxide. Simple as that. It forms sodium oxide. So if you know that a metal plus oxygen, it gives you this, then you won't go wrong. You will not go wrong. Number five, you should know that an acid plus metal carbonates. A metal carbonate is an example is zinc carbonate, sodium carbonate, magnesium carbonate. That's what we call metal carbonate, because you see I'm putting a metal and then the carbonate. Magnesium carbonate, aluminium carbonate, although we don't have that. So what does it give you? So if it is an acid, any acid that is reacting with a metal carbonate, you should expect the metal salt. You should expect carbon dioxide. Allow me to write in the carbon dioxide and then plus water. So an acid plus a metal carbonate, it gives you the metal salt, carbon dioxide plus water. For example, acid, let me use HCl plus zinc carbonate. It will form zinc chloride, because the chloride will come from here. It will form zinc chloride plus CO2 plus water. So So as you can see, this one is permanent. Any carbonate with an acid will form this. The only difference will be on the salt side. So we will put 2 here to balance the equation. Number 6, an acid plus a base. First, I realize very many people do not know what are bases. We have 2 types of bases. Let me describe them here shortly. Base, we have 2 types: metal oxides and metal hydroxides are bases. For example, here, zinc oxide, magnesium oxide, these are the bases. They are called the bases. Sodium hydroxide, potassium hydroxide, these are the bases. So whenever you see an hydroxide reacting with an acid, whenever you see a metal oxide reacting with an acid, that one is a base. So an acid plus a base will give you the salt, metal salt, plus simply water. For example, magnesium oxide plus nitric acid, H2, nitric acid is HNO3. It forms the metal salt. The metal is magnesium, you write magnesium. The salt comes from the nitric acid, so magnesium nitrate plus water. As simple as that. So you see, this general information is very, very important for you to write correct chemical equations, correct chemical formulas, and then balance the equation. Number 7. Reactions that form insoluble salts. So those reactions that form insoluble salt, you should know how the products that are. For example, I'm going to give an example: sodium carbonate plus magnesium chloride. This reaction, now sodium carbonate is reacting with magnesium. This is a double decomposition reaction or a precipitation reaction. Therefore, they will change the cations and the anions. So the cation this side will take the anion this side. The cation this side will take the anion this side. So this one is going to form magnesium carbonate plus sodium chloride. Then we will put 2 here to balance the equation. This one is a solid, aqueous. So this is how it's going to react. But if you have a problem here, I have done a video on salts, how to prepare insoluble salts. It is in the description. You would check the link and go and look at it. So there is a complete video for insoluble salts, reactions, all of those. I think up to that point, I want to thank you for your time. Number 8, effect of heat on nitrates. In short, we are saying, what are the products formed when nitrates are being heated? Here we have 3 scenarios. We have 3 scenarios where nitrates of the most reactive metals, when heated, they give different compounds. Like nitrates of potassium nitrate and sodium nitrate, when they are heated, they give potassium nitrate plus oxygen. The similar here, sodium nitrate plus oxygen, right? You can balance the equation like that. So you should know that nitrates of the most reactive metals, they decompose on heating to form the corresponding nitrite plus oxygen. The rest except those of silver, Ag, mercury, decompose to give the oxide nitrogen 4 and oxygen. So this is what I'm saying. Now those that are in the reactivity, the middle of the reactivity series, such as copper nitrate, zinc nitrate, all of those, they decompose. The rest, let me write that the rest except silver nitrate and mercury nitrate decompose giving, so let me say they giving what? Giving the metal oxide plus nitrogen 4 plus oxygen. For example, if it is zinc nitrate, when you heat zinc nitrate, it will give you zinc oxide plus nitrogen 4 plus oxygen. All of them will behave like this except potassium nitrate, sodium nitrate, and silver nitrate, mercury nitrate. The rest will behave like this. If it is copper nitrate, it will give you copper 2 oxide, nitrogen 4 plus oxygen. So what happens to silver and mercury? So silver Ag nitrate decompose on heating to give you silver itself plus nitrogen 4 plus oxygen. That is the difference. Mercury will decompose when heated to give you mercury itself plus nitrogen 4 plus oxygen. So you can see the scenarios I was talking about, that for silver nitrate, mercury nitrate has a valence of 2, you should know that. Silver is valence 1. It gives a metal. Silver will give you silver, which is a metal. Unlike the ones that are in the middle, the most reactive and those that are least reactive down there, they behave differently. So those are the things you must put in mind for you to score a lot of marks in chemistry, paper 1 and paper 2. Another important thing you should note is the colors of the oxides. You should know that copper 2 oxide is black, zinc oxide is white when cold, and yellow when hot. So those things you should also know them, because they are very, very important in helping you to unravel some kind of questions being asked. Number 9, effect of heat on carbonates. In other words, we are saying, what are the products formed when carbonates are being heated? When you heat a carbonate, what are the products formed? First, you should know that carbonates of potassium, carbonates of sodium, they do not decompose. So sodium carbonate, potassium carbonate, they don't decompose. Don't decompose when heated, because when they are pure, they cannot decompose. But the rest of the metal carbonates decompose when heated to form this. So let me generally write that metal carbonate. When you heat a metal carbonate, it decomposes to give you the metal oxide plus carbon 4 oxide, as simple as that. For example, you can take zinc carbonate. It will decompose to give you zinc oxide plus CO2. Simple as that. So all carbonates will decompose to give you the metal oxide plus carbon 4 oxide, except potassium carbonate and sodium carbonate, because they do not decompose on heating. Other reactions that you must also know.